An air brake or, more formally, a compressed air brake system, is a type of friction brake for vehicles in which compressed air pressing on a piston is used to apply the pressure to the brake pad needed to stop the vehicle. Air brakes are used in large heavy vehicles, particularly those having multiple trailers which must be linked into the brake system, such as trucks, buses, trailers, and semi-trailers, in addition to their use in railroad trains. George Westinghouse first developed air brakes for use in railway service. He patented a safer air brake on March 5, 1872. Westinghouse made numerous alterations to improve his air-pressured brake invention, which led to various forms of the automatic brake. In the early 20th century, after its advantages were proven in railway use, it was adopted by manufacturers of trucks and heavy road vehicles. Design and function: air brake systems are typically used on heavy trucks and buses. The system consists of service brakes, parking brakes, a control pedal, and an air storage tank. For the parking brake, there is a disc or drum brake arrangement which is designed to be held in the applied position by spring pressure. Air pressure must be produced to release these spring brake parking brakes. For the service brakes to be applied, the brake pedal is pushed, routing the air under pressure to the brake chamber, causing the brake to be engaged. Most types of truck air brakes are drum brakes, though there is an increasing trend towards the use of disc brakes in this application. The air compressor draws filtered air from the atmosphere and forces it into high-pressure reservoirs at around 120 psi. Most heavy vehicles have a gauge within the driver's view, indicating the availability of air pressure for safe vehicle operation, often including warning tones or lights. Setting of the parking emergency brake releases the pressurized air in the lines between the compressed air storage tank and the brakes, thus allowing the spring-actuated parking brake to engage. A sudden loss of air pressure would result in full spring brake pressure immediately. A compressed air brake system is divided into a supply system and a control system. The supply system compresses, stores and supplies high-pressure air to the control system as well as to additional air-operated auxiliary truck systems. Supply system. The air compressor is driven by the engine either by crankshaft pulley via a belt or directly from the engine timing gears. It is lubricated and cooled by the engine lubrication and cooling systems. Compressed air is first routed through a cooling coil and into an air dryer which removes moisture and oil impurities and also may include a pressure regulator, safety valve and smaller purge reservoir. As an alternative to the air dryer, the supply system can be equipped with an anti-freeze device and oil separator. The compressed air is then stored in a reservoir from which it is then distributed via a four-way protection valve into the front and rear brake circuit air reservoir, a parking brake reservoir and an auxiliary air supply distribution point. The system also includes various check, pressure limiting, drain and safety valves. Air brake systems may include a wig-wag device which deploys to warn the driver if the system air pressure drops too low. Control system. The control system is further divided into two service brake circuits, the parking brake circuit and the trailer brake circuit. This dual brake circuit is further split into front and rear wheel circuits which receive compressed air from their individual reservoirs for added safety in case of an air leak. The service brakes are applied by means of a brake pedal air valve which regulates both circuits. The parking brake is the air-operated spring brake type where it's applied by spring force in the spring brake cylinder and released by compressed air via hand control valve. The trailer brake consists of a direct two-line system, the supply line and the separate control or service line. The supply line receives air from the prime mover park brake air tank via a park brake relay valve and the control line is regulated via the trailer brake relay valve. The operating signals for the relay are provided by the prime mover brake pedal air valve, trailer service brake hand control and the prime mover park brake hand control. Advantages: air brakes are used as an alternative to hydraulic brakes which are used on lighter vehicles such as automobiles. Hydraulic brakes use a liquid to transfer pressure from the brake pedal to the brake shoe to stop the vehicle. Air brakes have several advantages for large multi-trailer vehicles. The supply of air is unlimited, so the brake system can never run out of its operating fluid, as hydraulic brakes can. Minor leaks do not result in brake failures. Airline couplings are easier to attach and detach than hydraulic lines. There is no danger of letting air into hydraulic fluid. So air brake circuits of trailers can be attached and removed easily by operators with little training. Air not only serves as a fluid for transmission of force, but also stores potential energy. So it can serve to control the force applied. Air brake systems include an air tank that stores sufficient energy to stop the vehicle if the compressor fails. Air brakes are effective even with considerable leakage, so an air brake system can be designed with sufficient fail-safe capacity to stop the vehicle safely even when leaking. Driving technique and operator licensing. As air brakes must be operated differently from more common hydraulic systems, most countries require additional training and licensing in order to legally drive any vehicle using an air brake system. Driving a vehicle with air brakes requires basic knowledge of proper maintenance as well. A driver is required to inspect the air pressurization system prior to driving and make sure all tanks are in working order. In addition, the manner of applying brakes is usually different from regular hydraulic-type systems. Pressure is applied slowly and air levels must be monitored at all times, as a loss in air pressure will result in brake lockup, also known as dynamiting. Unlike hydraulic brakes, air brakes must not be pumped repeatedly, as the repetitive application and release of air will drain the system prematurely. See also. References. State of California, copyright 2003, California Commercial Driver Handbook, Sec 5, North American Standard Inspection Program, Commercial Vehicle Safety Alliance. Tractor Protection Systems. Retrieved September 7, 2006 from Commercial Vehicle Safety Alliance. External links. The short film Air Brakes: Principles of Operation is available for free download at the Internet Archive. More